What's up, y'all? It's Mr. Canada. In this video, we're going to be talking about vertical and horizontal lines. We're going to learn how to write their equation and also how to identify their slope / rate of change. Let's get started. So let's say that they give us a horizontal line and they asked you, hey, what's the equation and what's the rate of change? Or maybe what's the slope of this line? So one of the things we kind of want to discover first is how exactly we write the equation for something like this, because it's not your typical line that we would normally graph. So one thing that you want to kind of look out for is a pattern in all of the points that are in the line there. So for example, let's go ahead and put some points on this line. I'm going to spread them out so it's easier to see the numbers. What would be the coordinates for this point? Well, remember that you always put the coordinates in terms of x and y. So this point right here would be the point 3, 2. The coordinates for this point right here would be 1, 2. The coordinates for this one would be -2, 2, and then the coordinates for this one would be -5, 2. Do you see something strange about or something cool about all of these points? Notice that the y value for all of these points happen to be the same. They happen to all be a value of 2. So what does that mean? Is that just a coincidence, or is it supposed to be that way? Well, the cool thing about horizontal lines is that depending on what kind of y value they go through on the y-axis, the y value of every single coordinate point is going to be the same. So that actually gives you a hint about how to write this equation. So anytime you have a horizontal line, pay attention to what the y value is for every single point, or pay attention to what y value it's crossing on the y-axis, because that is going to be the equation for a horizontal line. So a horizontal line like this one will always have an equation of y equals whatever number you're working with. In this case, we were working with y equals 2. So we could say that the equation for this line would be y equals 2. So now how exactly do we take, let's say, an equation already given to us, and how do we graph that? So let's just say that they told us, hey, I want you to graph y equals -3. So what should you do? Well, whenever you see y equals just by itself, that means it's going to be a horizontal line. So all you have to do is look on the y-axis, put a point on -3, and then draw a straight line, a flat line going through that point. That's the only thing you have to do if you want to graph a horizontal line, or if you want to graph an equation where it's y equals just a number like y equals -3. Well, okay, what about an example like y equals 0? Well, where is 0 on my y-axis? It's right here. So I'm going to go ahead and put a point at the 0, and then I'm going to draw my flat line going through that point. So this one would be y equals 0, and I'm going to go ahead and label this one as y equals -3. That's it. It's pretty simple and it's pretty straightforward. So now let's go ahead and answer the question of, well, how exactly do we start getting the slope out of this? Well, think about this for a second. Slope is always talking about a rate of change, or in this case, whenever we talk about a line graph, we always talk about rise over run, because it's the easiest way to think about or to calculate the slope if they give us a line graph. So one thing that you could ask yourself is, what kind of rise does this graph have and what kind of run does this graph have? Well, in this case, the easiest way to do that is just pick 2 points and go ahead and do the slope formula, or just think about, well, does it have rise or does it have run? In this case, look at the orange line we had before. Ask yourself which of the 2 it has and which of the 2 it's missing. In this case, this graph, this orange line, only has a run because it's going from left to right constantly. This would not have a rise because you don't see this orange line going up or going down. So one thing you could say is that with horizontal lines, it has a rise of 0 because it's not going up or down. It only has horizontal distance. It's just on the ground. And then the run can be pretty much anything you want. So because the rise is always going to be 0 regardless of where you are on that horizontal line, that means that the slope of a horizontal line will always be 0 regardless of what the run is. That means that even if the run was 5, 10, or even a negative number, as long as the numerator is 0, your slope of a horizontal line or a line that's just on the ground will always be 0. Again, why is it 0? Because it does not have any rise whatsoever. Okay, so now that we've looked at the equation and the slope of a horizontal line, let's go ahead and see what else we can learn about vertical lines. So let's go ahead and take the same approach as we did with the horizontal line. So this right here, this is a vertical line because it's going up and down. And let's go ahead and space out some points on here. Let's go ahead and put some points out there in space. Again, let's think about the coordinates of every single point on here. The coordinates for this one would be -4, 5. This one would be -4, 2. This one would be -4, -2. And then this one would be -4, -5. Is there something peculiar about all of these points? You might notice that all of the x values are the same no matter what point we actually ended up choosing on this line. And that's the defining feature of a vertical line. All of the x values of a vertical line will be the exact same thing. So the easiest way to think about this is think about where is this vertical line crossing on the x-axis, because that is going to be your equation. In this case, this red line is crossing at -4. So that means your equation for this red line will be x equals -4 because all of the x values are the same. So what's the idea? The idea is that when you're working with a vertical line, the equation will always be x equals whatever number you're working with. Again, let's go ahead and look into some other examples. What if they asked us to graph x equals 1? Well, think about where's 1 on my x-axis. It's right here. So all we're going to do is we're going to draw a vertical line going through that value of x. Simple. What if they asked you to go ahead and put a line at x equals 0? Okay, where does x equal 0 on my x-axis? It's right here. We're going to go ahead and draw a vertical line going through that point, and then there's my equation. So whenever they ask you to graph x equals a number, that's going to be a vertical line going through that number on the x-axis. Okay, now let's talk about the slope of this line. Again, what you want to ask yourself is which value of rise over run is it missing? So if slope is rise over run, think about all the vertical lines that we've been working with so far. Does this always have a rise or does this always have a run? Well, in this case, this line is always going up and down. So that means that this type of equation or this type of line will always have a rise. So it doesn't matter what that rise is. It can be a rise of 1, of 2, of 10, 1,000, doesn't matter. It's just shooting off into space. But does this graph have a run? Well, we don't see this graph going left or right. It's not going side to side. So that means that this is having a missing value or a value of 0 for the run. One peculiar thing that you have to look here is that you're dividing the rise, regardless of what that number is, by 0. So what you have to think about is what happens when you divide a number by 0. For example, let's say you had 2 divided by 0. What happens? Well, if you were to put this on a calculator, you would get an error, or they will tell you that the value is undefined. So that's just what the slope is. The slope of a vertical line will always be undefined because it does not have any type of run, and the run is always at the denominator. And again, if you want an example, think of it as you're taking a 2 and you're dividing it by 0. Now, this is the basic ideas of horizontal lines and vertical lines, but sometimes it's a lot of information to remember. So here's a very short acronym that I like to use for both the horizontal lines and the vertical lines. So the first acronym is this one, HOY. Think of it like the Spanish word today. It basically says hoy. So the first letter of this acronym describes what type of line you're working with. So that means that the H here stands for horizontal. The middle part always tells you what kind of slope you have. In this case, the letter O looks like the number 0, so that should tell you that the slope is 0. And then finally, the last letter tells you what kind of equation you have. So that means that if you have a horizontal line, your equation will always be y equals. Likewise, we have a very similar acronym for vertical lines. We have the word VUX. Again, the first letter tells you what kind of line we have. We have a vertical line. The letter in the middle tells you what kind of slope we have. This is going to be an undefined slope. And the last letter will tell you what kind of equation we have. It's going to be x equals so and so. So what's the big idea with vertical lines and horizontal lines? Basically, horizontal lines will always have an equation of y equals. So whatever that number is, it's always going to go through the y-axis and it's going to be a horizontal line. The slope of a horizontal line will always be 0. On the flip side, if you have a vertical line, their equation will always be x equals whatever number it's crossing on the x-axis. And the slope of those graphs will be undefined. If you have any questions, please leave them in the comments below and I'll get to you as soon as I can. If you liked the video, give this video a like and subscribe to my channel for more Algebra 1 videos. As always, please take care and I'll see you guys next time.